Welcome, my friends. In this video, I will begin my discussion of Chapter 5, Estimating a Population Parameter. I'll be covering Section 5.1, which is titled, What is a Confidence Interval? Confidence intervals are an example of inferential statistics, when we're trying to say something about the population based on a sample. For confidence intervals, we will be trying to estimate the value of a population parameter, such as the population mean or the population proportion, using just a sample. Let's begin with a motivating example. Let's say that I would like to estimate the population mean amount of student debt for all recent Grand Valley graduates. So here we have a Grand Valley graduate, and he is carrying the tears of his student loans, hoping that he's able to find a job pretty soon and be able to pay off his debt. And let's just say that we are trying to estimate the population mean student debt for all of the recent Grand Valley graduates. Now notice that I'm using the symbol mu here to represent the population mean. But most likely, I'm not going to be able to gather data from all of the recent Grand Valley graduates. So instead, I'm going to be settling for a sample. So let's assume that I sample 100 recent Grand Valley graduates, and I find the sample mean, x bar, to be $20,000. Since my mean is only based on a sample, it probably does not perfectly represent the population mean student debt of all recent Grand Valley graduates. I would need a census of all of the recent Grand Valley graduates to find this value exactly. So most likely this 20,000 could be maybe a little bit too high or perhaps a little bit too low. But nevertheless, this is an estimate for that population mean student debt. The statistical term that we use here is a point estimate. We would say that the sample mean is a point estimate for the population mean. In other words, we don't really know what the population mean student debt is of all recent Grand Valley graduates, but our estimate of that value is $20,000 based on our sample. Now, as we've already stated, that $20,000 estimate is probably not a perfect point estimate for the population mean. So instead of just relying on that single number, we create what is called a confidence interval, which is centered around that value. And I think the best way to view that is to look at the number line. So on a number line, we would put right in the middle our point estimate, in this case, the sample mean of $20,000. And then we're going to add and subtract some margin of error to get to what we call a lower bound, let's say 19,500, and upper bound, let's say 20,500. The distance between the point estimate to either the lower bound or the upper bound is what we call the error, and is $500 in this example. So now, instead of just saying that we think the population mean is pretty close to $20,000, we might say that we are 95% sure that the true population mean falls somewhere between our lower bound and our upper bound of 19,500 and 20,500. We will discuss how to calculate the margin of error from a sample in a future section, which incorporates the level of confidence, the sample standard deviation, as well as the sample size. For now, know that the point estimate, which is our best estimate of the value of a population parameter, will go in the center of our confidence interval, and then we'll be adding and subtracting some margin of error to reach our upper and lower bounds of the confidence interval. Note that we could also apply this same idea to other population parameters. So for example, if we'd like to estimate the population proportion, then we would have the sample proportion of p hat as our point estimate in the middle of our confidence interval. Okay, here's a problem for you to try. If a 95% confidence interval for the population mean final exam score in Stat 215 at Grand Valley State University is from 72 to 84, answer the following. Note that this is just one way you can write a confidence interval, with an open parentheses, then the lower bound of the interval, comma, the upper bound of the interval, and then close parentheses. So you are asked for the value of the point estimate, the value directly in the middle of our confidence interval, as well as the margin of error. So go ahead and pause the video and give those two problems a shot. Now, theoretically, any confidence level can be used, but the most common confidence levels are 90%, 95%, and 99%, which represents the chance that the parameter you're trying to estimate falls inside your confidence interval. The higher the confidence level that you use, the higher the margin of error. The 90% confidence level is the lowest confidence level that's traditionally used, and therefore it's going to have the lowest error. It might look something like this. We'll have our point estimate in the middle, and then a small amount of error to get to our lower bound, and then up to our upper bound. The 95% confidence interval is the most common type of confidence interval and is going to have a medium amount of error, so a little bit higher error from the point estimate to the upper or lower bound. The 99% confidence interval is the highest traditionally used confidence level percent, and therefore it's going to have the highest error. So we're going to have the largest distance from the point estimate to either the upper or the lower bound. Now, one might ask, why is it the case that when you increase your confidence level, you're also increasing your margin of error? Well, we'll see exactly why that's the case when we look at the formulas in a future section, but intuitively, if you want a higher chance of capturing the population parameter within your interval, then one way to do that would be to increase the size of the interval and therefore increase the margin of error. If you have more numbers inside your interval, then you're going to have a higher chance of actually capturing whatever number you're trying to capture inside that interval. So therefore, whenever you increase the confidence level, you're also going to be increasing the margin of error. Now, there's one other thing that can change the margin of error, and that is the sample size. So if you increase the sample size, you'll actually be decreasing the margin of error. So make sure you know those two things that affect the margin of error. If you increase the confidence level, you're actually increasing the margin of error. And if you increase the sample size, you're actually decreasing the margin of error. Okay, the last thing to talk about is how to interpret a one-sample confidence interval. We will cover two sample confidence intervals in a different chapter, which will have their own interpretation statement. For any one sample confidence interval, you should state that we are C% confident that the interval between our lower bound and our upper bound contains the either population mean or population proportion, which are the only two population parameters we will be estimating in this class. Make sure that you describe the population mean or population proportion as it relates to your specific problem. Let's take a look at an example. Let's say we have a 90% confidence interval, which ranges from $19,500 to $20,500 for the mean student debt of a recent Grand Valley graduate. If we were interpreting this confidence interval, we might say that we are 90% confident that the interval between our lower bound, which is $19,500, and our upper bound of $20,500 contains the population mean student debt of a recent Grand Valley graduate. So make sure you don't leave the last part as simply the population mean or population proportion, and you put it into context with whatever variable you're dealing with. All right, that's everything I wanted to talk about in this video. I'll see you in the next one to talk about the details of the confidence interval for the population proportion.